In this problem, we have a multiple decrement table. We're given three decrements: death, disability, and withdrawal. We're given q prime 60. First decrement is 0.01. Q prime of 60, decrement 2 is 0.05. And then the third is 0.1. Withdrawals occur only at the end of the year. Okay. So decrements 1 and 2 occur throughout the year, but withdrawal only occurs at the end of the year. Mortality and disability are uniformly distributed over each year of age in the associated single decrement table. So keep in mind, this is only the two decrements are uniformly distributed, not all three. So we can't use any of the associated single decrement formulas for this. Okay. So this is what we're going to do. We're going to consider two scenarios. First one is the probability that we reach the end of the year. Well, we only have to worry about two decrements if we want to reach the end of the year, namely the death and disability. Withdrawal occurs at the end of the year, so that doesn't affect us reaching the end of the year. So we're going to multiply p prime of 1 is 60 and p prime decrement 2 of age 60. So for that, we're going to use the complement, so it'll be 1 minus 0.01 times 1 minus 0.05. So this is 0.99 times 0.95, and that's 0.9405. Okay, the second scenario, we're going to consider the probability remaining through the year. So not only do we make it at the end of the year, but we stay there. So now we're going to consider all three decrements, because not only do we have to make it to the end of the year, which is the first two decrements, but we want to stay there. So we don't want to withdraw. So that's 1 minus 0.01 times 1 minus 0.05 times 1 minus 0.1. So we end up getting 0.84645. So now we want to look at the probability of exiting at the end of the year. So let's say if we started with 10,000 people, 9,405 would make it to the end of the year, and then the people who would remain there are 8,464.5. So we would just take the difference between those who made it at the end of the year and those who remained at the end of the year. So we're just going to subtract the two. And get the probability is 0.09405.